Hello, everyone. This is Ziad Sabbah, and I'm the moderator of this session. Nowadays, AI is trained on the cloud, on centralized data, having regulatory constraints and large latency. New algorithms advances as federated learning allow sharing the learnings without sharing the data itself with full data privacy. Many applications and use cases benefit from federated learning will be presented. Also, you will learn the requirements your project needs to set it up. I'm happy to introduce Dr. Maria Börner, the program manager at Adap. She has in physics and academic background in data analysis and processing. During her PhD, she worked at the world's largest particle colliders, CERN and DAISY, and previously she managed AI projects at Xane and was responsible for releasing them for Porsche, PwC, and Daimler. Without further ado, over to you, Dr. Maria.
Thank you very much for the introduction, and thank you very much for the invitation. So that I can present today federated learning in production and how you can use it, and what are the advantages of federated learning. So first to myself, I'm Dr. Maria Börner. I'm a program manager at Adap, and within Adap we build a platform that allows companies to use AI where the data is instead of moving the data to the AI. So this allows to share knowledge and learnings, but do not share the data because, for example, of privacy issues. So let's start. So the problem of today with centralized learning or with AI models are the following. So mostly you have different types of devices that have like data. So for example, on your phone, you have a lot of data. But in order to use this type of data and to make AI models, you have to move the kind of data to the cloud or to the server. And the server collects different types of data and performs trainings on these data. And the problem here is that if you have to move large amount of data, you have high latency and a very low availability. You also have like battery and network issues here. And of course, privacy and regulation issues. And also, if you think about collecting all these data, then you also have to think about big data architecture within the cloud. This is quite complex and also very expensive. So nowadays in North America, like every person has like 7 devices, smartphones, for example, or other edge devices. And by 2030, it will be even more devices that will come into the game, and you even produce more and more data. And we want to make this data usable for everyone. And how you can make it profit out of the data without sharing your information and without having this privacy issue, we can use federated learning. So with federated learning, you move the AI to the data. So that means on your smartphone, most of the smartphones, they are already ready to use AI trainings on them. So on your data is on your smartphone is your data located, and based on this data, you perform your AI training. These AI models can be sent to the cloud or to a server, and the server can collect different AI models from different devices. And therefore, we have very good availability because we only move like small data to the cloud. We do not need a very large bandwidth. And we do not have regulation issues because the data stays on your phone, for example. However, we make the learnings from the AI model available for everyone. This is a very big advantage. And also in the future, more and more edge devices will be AI ready. So in the future, federated learning will be more and more important. So if you think of the past, then we were only thinking about data that was located on your computer, for example. Nowadays, we have a lot of data on your smartphone, and the number of devices that produce data becomes more and more. And at the moment, we do not use this kind of data. We do not use really the data on your car, on your smartwatch, or on agriculture machines or something else. We do not really use it, but in future, we can make a profit out of this data. But it's very important to not share this kind of data, because I don't want to be sitting in my car and knowing that a picture of my face goes into the cloud of the server or somewhere, so that everyone can identify myself. So it's really important that we keep the privacy here, and that we use federated learning to share knowledge, so from other cars, from other drivers, but that we do not share the data here. So if federated learning is that important, why not everyone is using it already? So the question, or the answer here, is very simple. It's the complexity of federated learning. Federated learning is quite complex in the sense of hyperparameters. So normal AI models, they already have a lot of hyperparameters to tune, but federated learning has even more hyperparameters. It is also quite complex in the architecture. And also, if you think about the heterogeneity of devices that we have to connect, then it's even more complicated. Just think of the fact that we have different types of networks, or we have different types of platforms like Linux, Windows, Mac, Android, embedded, or whatsoever. Federated learning has to work with all these kind of platforms. And also, if you want to use federated learning for different types of machine learning stuff, it also has to be working together with TensorFlow, PyTorch, JAX, MXNet, and future frameworks. So the heterogeneity of machine learning stuff is quite big. So, and this is also a big issue for the production, because if we have so much different types of networks, platform, hardware, it's very difficult to use federated learning within the production. However, within an open source framework that is called Flower, we can solve these problems of heterogeneity, because Flower is very agnostic to platform, and also to network, and all the different stuff you can imagine, and I just explained to you. So Flower is here to accelerate the adoption of federated learning approaches. And Flower, you can split Flower into 4 layers. So the very bottom layer is the client layer. So here the client layer is for smartphones, for server, or for Roombas or machines or whatsoever. The next level on top is the network to the federation process. The third level is the federation itself. And the federation within Flower is working with the 4th layer, the federated learning and federated analytics. So federated learning and analytics are very similar in the architecture, but the idea is a little bit different. So within federated learning, you aggregate the machine learning models of all the clients that are connected to the federation. And within federated analytics, you just collect all the analytics results from all your devices. Within Flowers, you have now the possibility to use different strategy to aggregate all your information. You can, for example, use federate averaging, where you simply average all your AI model information, or you can use more sophisticated averaging processes like FedProx or whatever. Within Flower, you can also monitor the whole process and validate your process. So why is Flower that agnostic and can be used in different, together with different platform or frameworks? So the magic is more or less that Flower is really agnostic to the clients that are connected. So you have your local data, for example, on your computer, and as a machine learning engineer, I can simply use my data and make like a training pipeline. So it's just set up my machine learning project based on my data, and then I have a centralized training. Based on this training, I can now place a Flower and federate the whole process. So Flower is doing the whole magic of connecting to the server and aggregating my machine learning model and doing strategies and whatsoever. So Flower offers you already some pre-existing high-level SDKs, for example, with Python. So it's quite to use it together with Python. There are many things already available. However, Flower has the flexibility that you can create your own SDK. For example, if you have like C++, you can just create your own SDK, and you can just, within creating your own SDK, create the event handling and the connection, and that's it. The whole federation process itself, how you want to aggregate your information, your AI models, is done by Flower. If the aggregation strategy is not available within Flower, you can even create your own strategy if you want. So it's very easy to implement, even for researchers, your own strategy and check what is the best option or setup for your machine learning workload. So I just say it's very easy, but I also want to show you that it's very easy. So here I just show you an implementation example. So this implementation example is based on TensorFlow. And here you see in the upper big screen, you just see the client code. And in the lower button, you see the server code. And these both code snippets is everything you need to set up your federated learning process and together with a client. So first of all, you import your Flower and TensorFlow packages, as you would know it from Python coding. And then you just load your AI model. In this case, we have here a mobile net. And then you just load your data set here. In this case, we have a Cypher 10 data set. And in order to run your model federated, you now define your Flower client. And for this, you only need to call 3 callbacks: get parameters, fit, and evaluate. So get parameters is here to read and write your model parameters that you want to aggregate. The fit function here is to perform really the training. The training you can define by your own as you want. And the evaluation function evaluates your model training as you know it already. Then you just start your client and you also start your server, and that's it. You just have your centralized AI training federated. So it's really, really easy to use. So, and since Flower is so flexible and easy to use, it's all very good to use it within the production. Due to the fact that you can adjust everything on the client side, you have the possibility to use, for example, PyTorch, TensorFlow, NumPy, JAX, MXNet, and even other frameworks that might be available in the future. You can also use this with different platforms as Android, iOS, Linux, Windows, or Mac, whatsoever. And so the whole Flower package gives you a very unification way of using federated learning. So it's very easy to use, but you still have a lot of possibility to personalize it to your production use case. So our idea of when we created Flower was that we really wanted to have one toolkit for research and for deployment. It doesn't make sense to have only one toolkit for your research, and then you have to move your whole coding base to another toolkit because you cannot use it in deployment. So Flower covers really everything from research to deployment. So the normal way you would use or you go within the deployment or in production is that you set up, first of all, your AI machine learning stuff on your computer locally. You set up everything, and as soon as you have set up everything, you move it to the clusters. And within the clusters, you test the real world problem. If it is really stable of like device clusters, like Raspberry Pis, for example, or smartphone Android devices. And within the high performance cluster, you would also check if your federation process is really scalable. And just to mention, I just forgot about it in the previous slide, Flower is really proven also to handle up to 10,000 connected devices. So in the high performance cluster, you can also check how your federation process is working and how many local trainings you would need in order to get a very good results of your federation process. As soon as you have tested your real world environment, let's say, you can move to deployment and without a big issue because you have tested it already on the device farm and you have also tested the scalability. So more or less at the end, I also would like to show you some use cases that we already implemented or where we implemented Flower in. So first of all, we have a use case together with machines. So here in this use cases, we have like different companies. They are having a machine, and this kind of machine, they are producing some screws. And these kind of machines, they measure different stuff, for example, temperature, movements, or position, and everything. And based on this information, they are training a predictive maintenance model. However, since these since failures that you need for these kind of models appear very rarely, it is not enough for only one company to get a very good AI model. So here, in order to increase the number of failure cases, you would connect the companies to each other and share the AI knowledge with each other. The data always stays on the machines, so you do not have any privacy issues, but you learn from other companies having similar failures. So this is a very, very good use case for federated learning. And especially if you think about a company that's connected new to this kind of networks, and they do not have any previous failure cases. So if they would just be standalone, they would not have any knowledge about failure cases or predictive maintenance or something. So, however, if they use federated learning within this kind of network, they would not have any cold start issue because other companies, they already pre-trained the model, and the new company can just use this kind of knowledge. So a very good use case here. Another use case is our chatbot. So for this use case here, we have like different organizations, also again connected together via federated learning. And here we are sharing HR chatbots. So employees, for example, they can ask HR-related topics to the chatbots. So for example, how long is my parental leave, or how much money do I get within my parental leave? And they receive some answers from the chatbots. However, the answers or the questions, they will never leave the company, and they will stay within the company. However, this knowledge from the chatbot and the training, they will be shared with other companies. So the advantage is here that we have more bot interactions and better predictions for each employees, but no data exchange between other companies. And also, if we have a new company who want to join this kind of network, they do not have any cold start issue. They directly start with a very good AI training model. And the very last use case for federated learning we can find here in agriculture. So we have a little joke about agriculture because these kind of machines, they are on the landscape, and they are making videos and images to identify weed or a water level. And the problem of making this data usable is that they have 0G network. So it's a very big issue here. You can imagine that the problem here for this machine is not really data privacy, because nobody cares about images of some plants or so. Yeah, the problem is here really that we do not have any network connections. So we have to keep the data on the machine itself, train based on these machines, training an AI model, and this AI model is then shared within a network. Of course, you say now, okay, but we do not have any network connections. But of course, these machines, they go into the parking position at home, then they have Wi-Fi available, and then they just move the AI model into the cloud, where everything is aggregated, and where the knowledge is will be made available. So here we have very good image cases, a lot of image cases. So we have better identification of water level in wheat. And of course, also if we have new machines coming into the network, we also do not have any cold start issue here. So this is a very different topic. So nothing about data privacy, but about network availability. So yeah, that's it more or less about federated learning for production. So I'm very happy to answer all your questions. And if you are interested in working with us, you can also contact me. directly or ask about more use cases that you can imagine.
Thank you, Dr. Maria, for this interesting topic. It's very interesting, and I myself have some questions. I've noticed that the examples that you have given were basically about things like manufacturing, in HR, stuff like that. So how do you see, what's your point of view on applying the flower model in between companies that use data heavily, such as marketing or advertising field, between these companies? Does it will it apply the same concept as the other examples that you have provided?
Yes, of course. I mean, you can imagine different types of AI models. Flower is very agnostic to the AI itself directly. So you can, for example, also use it for recommendation system as Netflix, for example. You can also imagine this kind of use cases. It's agnostic to any use cases. Yeah.
Mm-hmm.
Everywhere where you do not want to share data or information, you can use it.
Right. Nigel has a question regarding regarding Flower? Is it an open source or?
Yes. Flower is open source. You can use it. And of course, we're always happy to have some contributors. So if you have like new use cases or new strategies, how you aggregate stuff, you can also contribute. We are always increasing the number of examples. So I think like 2 weeks ago, we just added an MXNet example to Flower. So we are also heavily working on increasing the number of examples within Flowers. But we are also working, I have to say, together with the Oxford University or Cambridge University, who are also contributing a lot to this Flower framework. So everyone is welcome to contribute and also to use it, because every user who finds a bug or who's happy is always welcome, because improving Flower is very good for us.
That's great. So Ernest has a question. So he's asking, have you come across any use cases of federated learning in cybersecurity, since privacy is a big issue?
I mean, yeah, of course. I mean, you have different things that that you have to take into account. I mean, federated learning is, let's say, simply said, it is it allows data privacy by design. So yeah. However, in the future, there will be toolkits even to identify, based on your AI model, identifying the data. I mean, in the future, it might be available. So therefore, in the future, we will also add additional things, tools, to make it non-readable for other people. So you can imagine things like secure aggregation or differential privacy or something. Yeah. So everything's, we want to have it, we want to have full data privacy, and also at the end, full AI privacy.
That's awesome. Right. Let's stick for a minute or something and see if there are any questions from the audience. So just a question from my side. What languages other than Python does it apply to?
So at the moment, we just have this Python SDK. But as I said, it is also agnostic to C++ and to any other languages you can imagine. So you can just add your own SDKs. Yeah, of course, at the moment, machine learning is most popular within Python. So we have a lot of Python examples. But we also started with Java, having some Java application. So many things are possible.
Awesome. Right. I think that's it. That's very interesting and insightful as well. I'm glad I've had the opportunity to know more about federated learning from yourself, and sure I'll try to implement it in my work soon. So thank you for that.
Thank you very much. Thanks.
Appreciate it, Mike. Have a good one.
Bye bye.
Bye bye. Thank you for the audience.